Hello, my name is Mohammed Defu. I'll be presenting the final project for the course EEL6509 at the University of Florida. My project is the analysis and investigation of MIMO systems using BPSK modulation and the automotive scheme. In this project, I'm gonna give brief introduction to developing a MIMO system. Then I'm gonna compare the CSIL and MIMO system. Talk about the diversity techniques used in MIMO system, the procedure of operation in developing the MATLAB code, results of this project, and an analysis of this project. Then I'm going to end with a brief conclusion. Introduction. So, MIMO system have gained a lot of traction because of their higher data rate and higher channel capacity than CISO system. Also, MIMO system have a better link and spectral efficiency, which gives them a better BER performance for the TMSNR compared to CISO system. Also minimize the transmission power required in sending those information bits to the receiver, and they provide a good quality and high speed link. All those reasons were motivating in developing MIMO systems. CISO system, or single input signal output system. In CISO system, we have one transmitter antenna and one receiver antenna. We send the data stream from the transmitter, goes through your channel and then to the receiver. The result is of having one channel, one transmitter antenna, one receiver antenna. We're going to have one channel, which could be bad for communication, since if this channel is damaged or bad, received signals could vary significantly from the transmitted signal, which is bad for communication. The capacity of CISO system is governed by channel capacity theory, which says the capacity of the channel is a function of the bandwidth times the log 2 of 1 plus signal to noise ratio. So you can increase the capacity of a CISO system by increasing the, let's say, SNR, or increasing the bandwidth. One advantage of CISO system are they're very simple to design. And result because they have one transmitter antenna and one receiver antenna. And as a result, they're very cheap to build. But as I said earlier, they're very sensitive to channel interferences, because there's only one channel. If this channel is bad, the communication is bad. Multiple inputs, multiple output system, or MIMO systems, are systems that employ multiple transmitter antenna and multiple receiver antenna. As a result of this deployment of multiple antennas, we have spatial diversity, which can mitigate other impairments in the channel. So as you can see, we have you can have multiple data streams sent by multiple transmitter antenna and received by multiple receiver antenna at the output. The capacity of the channel is similar to the CISO system, but notice that the equation shown here shows that the capacity of channel is function of M times bandwidth log 2 of 1 plus SNR. And M is the number of streams to multiple antenna at the receiver. So if you have two receivers at the output, you're going to have M equal 2, then you're going to increase the capacity of channels for the same SNR, the same bandwidth of a CISO system by multiple of 2. And as you go on, so if you have 4 at the receiver, you're going to increase by the time of 4. And if you have 6 transmitter at the receiver, you're going to increase by the time of 6. And because of the diversity, the spatial diversity caused by the deployment of multiple antennas at the receiver or transmitter, that interferences can be limited. So for this project, we use BPSK modulation, or binary phase shift keying modulation, which is the simplest form of phase shift keying. BPSK is implemented through varying the phase on the functions and the basis function of the information bit. So if you get a signal, it's either a 1, a binary 1 or 0. So, and the constellation diagram shown here, it represents 1 or 0. So in the in-phase quadrature, it's +1 if it's a 1, or -1 if it's a 0. And they vary by 180 apart. Excuse me. Okay. In MIMO system, we deploy diversity techniques. So the question, what is diversity? Diversity is sending multiple copies of the same data through multiple transmitter antennas and received at multiple receive antennas simultaneously. This is the basic definition of diversity. Diversity could be frequency diversity, time diversity, spatial diversity. So why do we use diversity in beam system? So look, we have multiple transmitters and multiple receivers, so there's going to be multiband propagation, which can cause small or large scale fading, which is bad, which is an impairment of the channel, which makes the communication worse. So diversity can mitigate this problem of small scale fading. But with everything, there's an advantage also for multi-path propagation, because as I said earlier, when you have multiple antennas in the receiver, you can increase the capacity of the channel. So for the diversity technique used here was space-time block coding. So what is space-time coding? Space-time coding is a technique used in wireless systems to send multiple copies of data stream to the receiver antenna in order to improve the reliability of the channel and reliability of the data transfer. And it's going to be used using space diversity, multiple antennas at the receiver, multiple antennas at the transmitter, and time diversity by sending in different times. So we achieve space diversity and time diversity to mitigate the effect of fading channel. And why space-time coding? Space-time coding delivers maximum diversity without sacrificing the data rate and gives us a high throughput. Okay, so for this project we use the Almody space-time block coding. And this Almody is a space-time diversity technique that can be used in 2x1 meso mode systems or 2x2 mode system. And it's the only space-time block coding or space-time coding that can achieve full diversity gain without sacrificing the data rate. And this gives the Almody scheme a significant importance than other space-time block coding, because it doesn't sacrifice the data rate, although it has a lower BER performance than other space-time block codings. So you can see the figure here. At the first time slot, we group the transmitted symbol X1 and X2 together, and we send it. And that achieves a space diversity because we're grouping two symbols and sending them at the same time. And then at the second time slot, which achieves us time diversity, we send the conjugate of X1 and X2, which gives us diversity gain without sacrificing any of the data rate. So we go to the working principle of the Almody scheme. Let's explain it. For a 2x1 system, we got two transmitter antennas. As a result, we're going to have two channels sent to the receiver. And to the receiver. And if we assume and as I explained above, we send the symbol X1, X2, the transmitted symbol X1 and 2, and then they're conjugate in the second time slot. So if you assume the channel is Rayleigh fading, we can see that the received signal will be a function of the channel effect and the transmitted symbol plus the white noise. And the same thing will be done for the received signal at the second time slot. And using this equation of Y1 and Y2 and using the transmission matrix of the channel, we can estimate the transmitted symbol at the receiver and get an analysis of the bit error rate, the BER analysis. So, in developing the MATLAB code for the C system, we follow this procedure. We generate transmitted data or transmitted symbol we want to send. We perform on it GPS gate modulation. Then we multiply by the Rayleigh fading and add white Gaussian noise to implement the channel in MATLAB. And we do equalization on those on the received signals. Then we do a GPS gate modulation to get the received signal, and then we do a BER analysis. The same was done for MIMO system using Almody scheme. The difference is employing a space-time encoder before implementing the relay channel, and a space-time decoder before doing the PBSK modulation. Then we get the received signal here, and then we perform BER analysis on it. BER analysis. So if we go to show the MATLAB code,